Hello guys, today is lesson... can't count today. whatever lesson this is, we're going to be learning about ions. So I know the last episode was a bit confusing on chemical reactions. So we're reacting chemicals to get new chemicals, and that's a chemical reaction. I forgot to mention this the last episode, but a chemical reaction is when we're adding chemicals to get new chemicals. Okay? So we're now going to be learning about ions. So you need to remember these. These are absolutely crucial if you're going to do chemistry. These ones here, so you know how in the periodic table there's columns? There's columns in the periodic table. This side it's +1, +2, +3, +4. Then the way you go all the way over to this side, it becomes all the way to the right side, it becomes -1, -2, -3. So what's actually happening here? When we have ions, what happens essentially is this. So we all know what the proton, the neutron, and the electron are by now, if you've watched the videos. So we have something called electron configurations. So we need to know how many electrons we have in our outer shells. So this is going to be quite a long episode. Maybe not to make any more than 15-20 minutes long, but don't count me on it. So we know, let's grab another one, carbon. So carbon is 6, that's carbon, yeah? Let's have carbon. So carbon's going to have 6 protons and 6 neutrons in its nucleus, alright? Don't worry about the nucleus for this bit. Just pretend there's our carbon nucleus in there. Because that's where all our protons and neutrons are. And then we've got 6 electrons. Remember? Because 6 protons, 6 electrons. I'm just going to draw it as E minus. Now, the way the carbon one's going to work, it's going to look like this. It's going to look like this. You might go, why is there 2 here and then there's 4 in this one? This is where we get to electronic configuration. So electronic configuration for the first 20 elements goes like this, 2882. What this is saying, don't only worry about the first 20 elements for now. It gets completely different when you get past that, like SPDF, and it gets completely different. This is only for the first 20 elements, so first 20, so from hydrogen to calcium. So basically what we've got this. Hydrogen to calcium has this formula. So this is its first shell or ring. So these basically are all rings or shells, these lines, these circles. Second, third, fourth. So you say, okay, so that's how we go. So while I'm doing these, I'm going to try my best to keep that in the top corner here. So you guys can see 2882. That is our electronic configuration for the first 20 elements. That's basically the universal coverage. Think of it that way. So we've got that. So we're going to just all start. Let's grab an element. I'm going to tell you guys a question. Sodium. Draw its electron configurations. That's how we do that. We know we've got our nucleus. You can draw the protons and neutrons if the question asks you. For this purpose, I'm not going to though. Okay, because you guys should already know that's where the protons and the neutrons are. And how many protons and neutrons are in hydrogen? There's 1 proton, 0 neutrons. Helium, 2 protons, 2 neutrons, etc. So we've got 1, 2 electrons. So now its first shell is complete. Tick. We have 2 in the first shell. And sodium is 11. That's its atomic numbers. That's how many protons and electrons it's going to have. So then we've got 9 more. Then we know there's only 8 in this one. So you already go, okay, 2 plus 8 is 10. Plus 1 is, so its electronic configuration is going to be that. And you would be right. So let's draw this. 1, 2, 3, 4, 5, 6, 7. There's ours. So we've got 8 in our outer shell. There's 8, and in this inner shell there's 2. But then there's going to be this lonely electron on the outside. There's going to be 1 on the outside. So I go, okay, well, why is it a lonely electron? Isn't that how it works? And you're going to be like, no. This is where ions come into play. So this is actually where this is what ions are. So sodium say if the sodium atom has a 281 electron configuration, it wants to make a compound. I was like, okay, well, I want to go with a hydroxide. So the stuff, H plus OH is water, as I explained. And so there's a hydrox. Actually, let's say there's a chlorine. Chlorine is 17, so 2 plus 8 is 10, so it's going to be, this one is going to be 287. So we know that's got 11 electrons. That should allow up to 11 electrons at 17 because chlorine is element 17. So these two are like, okay, well, I want to share my electrons because I've got one loose one. Oh, I need one to make a full shell. This one's like, I want to get rid of this one so that I've got complete shells. It's like, oh, well, I need one more to get my shells up to 8 so that way mine are full. So these two actually get attracted to each other. So these two are, okay, let's share electrons. So we've got 281 for the sodium. Then we've got 287 for our chlorine. And we all know this is going to be sodium chloride or salt. Say a salt is actually formed. So then we got this, essentially. So I'm just now going to keep that in the top left corner so you guys can see it. So there's our two electron configurations. So the sodium is going to get rid of this electron and put it here. So now the sodium will be 2A. Like that, it's going to get rid of its electron. It's going to add it to the chlorine, which wants one. And this one wants to get as close to this way. And this one wants an extra electron to make a full shell. There you go. So now, but now you're going to say, well, what happened with the other electrons, apart from going to chlorine? Well, this is essentially what's happening. So now that it's lost its electron, it's going to have a charge. And this is what we call these charges of elements, we call ions. Or compounds, we call ions. So the sodium has given one. If it gives one, it's now Na plus, or plus 1. And the chlorine has accepted one. So it's accepted one. Positive means given electron. Negative means accepted electron. So now this one is given electrons, so it's going to have plus 1 charge. And this one's going to have a negative 1 charge because it's going off from the sodium. Chlorine has gone off from the sodium. Okay, so now we know our ions. You need to know some of the ions. So hydrogen has a column here. Then we want helium on this one. Noble gases, don't even worry about them. No, that's what we just call the group of all they're in groups. So hydrogen's not even in a group. These ones are called alkali metals. Then we have the next one, which is the alkali earth, which starts with, I'm actually going to draw this. We don't need this anymore. I'll write it down in case people still want it. So I have these hydrogen, beryllium, boron, carbon, oxygen, nitrogen. Okay. It's going to go all the way down on the periodic table. This is like a periodic table. Think of it as that. Alright, so here we have like how it looks. Now helium will be over here, but don't worry about noble gases. Because you guys want to know a fun fact? Noble gases do not react with anything at all. So you do not, you know why? And this is why. Because their electron shells are already full. So they don't have to get rid of or accept any electrons. That's why noble gases don't react with anything. Because their ion is 0. Added ion of 0. So hydrogen, lithium, all the way down. This is the first column. Have an ionic charge of plus 1. The next one over is plus 2. Plus 3, I think. Then plus minus 4. Minus 3. Minus 2. Minus 1. That's how it looks. So you might go, hey, this one's positive and minus because 4 is in the middle of between 0 and 8. So 4, if it's got 4, it can either give or lose. So that's your ions. Sort of looks like this. So now, this relates back to our question. Okay, I'm going to get rid of the 2882. You guys should know that by now. Now you might go, okay, so how come in water... Actually, no, let's go with a different compound. Let's say, okay, lithium chloride. So let's go hydrochloric acid instead. HCl. How come it's just that and not like HCl2, H2Cl, something like that? And this is where the ions come in. So there's also other ions. If I were to add, there's also other ions like hydroxide, which is a -1, sulfate, which is a -2. There's a lot of others. Okay? You can Google and like print out a sheet of all ions. In fact, I'll try to put a resource up on the useful resources tab on Dylan Teacher Science .x10host.com. If you guys want a resource of all the ions, let me know. So now we have that ions. So what if I add sodium? Actually, no. Yeah, let's go hydrogen. And I want it to add. So we know that's going to be a plus. H plus. +1, you just write as plus. So that wants to give its electrons because it's got one electron short and it's out of shell. So it wants to give an electron. Let's say, okay, something comes along. Big boy nitrate comes along. Nitrate is this. Nitrate is NO3, and this is another ion that's not just an element, but it's an ionic compound. So this would be -1 as well. So basically you want all these charges on the top to equal 0. Does +1 plus -1 equal 0? +1 minus 1 is 0. So that is just going to be one of each. Plus, minus. That's just going to be one of each because +1 minus 1 equals 0. You want to have 0 electrons flowing around, essentially. But now what if I want to have 2 of some? If I were to have... let's go calcium 2. Calcium is a 2 plus charge. And if I wanted to react that with, say, chlorine -1, okay? So that just +2 plus -1 equals 0. No, it equals 1. So we have a difference of 1. So what we need to do is we need to make the smaller charge be, remember, positive and negative also attract to each other. Keep that in mind. That is essentially what ions are, they're charges. Chlorine, we want that to be -2, so it'll balance with this one. But how do we make it a -2? Quite easily. We write it as this. We have 2 chlorines, because 2 plus, 2 times 1 minus equals -2. Now they balance. That's why we always put a 2 here. So where we've got 2 minus 1 chlorines, which will balance with the 1 calcium, that's 2 plus charge. If that makes sense. So we're just balancing the charges. In most cases, they're called ionic compounds. We'll learn about ionic bonding in some later episodes. But now you might go, okay, one more example, Dylan. And I'll go, okay, I always give examples. What about this one? What about if we had this? What about if we had this one? This has got 2 elements here, Dylan. How the hell do I do that? So you might be going, okay, in the question, okay, so magnesium OH2, yeah. You might think, okay, it's this. You would be wrong because you're only going the hydrogens 2, but keep in mind this oxygen is also attached to the hydroxide ion. So you also have to include the oxygen. So how the hell would I write that? You put in brackets, anything in this bracket now is by 2. Magnesium hydroxide would be like in brackets 2. Anything in that bracket is by 2. So essentially, I know this is another big lesson. Hopefully you've practiced your compounds a bit. You all need to know this. Group 1, which I'm going to basically draw a big table here, and I might even put a digital version on the website. Group, I'm going to write like a table. So group 1, group number, starts with an ionic charge. This makes sense. So, group number 1, which starts with hydrogen, has a +1 charge. I'm going to draw a few of these, so you guys sort of get the point. Group 2, which starts with beryllium, element 4, has a +2. 3, plus minus 4, minus 2, minus 1. There's also a minus, actually I'll draw this. So essentially what I'm now going to draw is this. I'm actually going to go, should I go portrait? No. So in group number 1, 2, 3, 4. Now dude, how do I draw this actually? This is hard. It's actually starting to do my head in. Alright, I'm not going to bother with group numbers. I'm going to go group starts with hydrogen, beryllium, so that'd be group 1, group 2. Beryllium, boron, carbon, nitrogen, oxygen, fluorine, and helium. Okay? And what's its ionic charge? So loose, in other words, loose electrons. For hydrogen, it's going to be +1, +2, +3. You might be also going, what about all the stuff in between? They do have charges, don't worry about them for now. +, -4, -3, -2, -1, and 0. So the groups that start with hydrogen includes lithium, cesium, potassium, sodium, that sort of stuff. Beryllium, magnesium, calcium. Boron has stuff like aluminium, that sort of stuff. Silicon, actually it's silicon, not aluminium. I know it is aluminium. Carbon has, like they all are in groups in the periodic table, right? So they're their charges. Okay. All I want you guys to know from this lesson is that are the ions of the elements, but there's also ions like nitrate, sulfate, carbonate, I'm also going to draw these ions. You guys should know these ones as well. These are basically, we call these ones, we don't call them nitrate, we call them nitrate ion. Sulfate ion, sorry I'm laughing at something. Sulfate ion, carbonate ion, and hydroxide ion. Hopefully that was enough of a brain fuck for you guys for today, and I hope you guys enjoyed.